Okay, as promised, I would like to work out question number 30 and question number 31 from the 7.6 homework. These questions are good questions for us to have practice with as it relates to all the things that we get to do in geometry. This is also a great example of a problem that is not difficult when we break it into smaller pieces. This is one that definitely qualifies as a longer problem, but definitely not a hard problem. The first and most obvious question with this is, where do we begin? The best place to begin is really where we see an angle and a side matched, and that's going to be in this triangle right here. The question here is to find, the question asks to find the perimeter of this object. So that means I need to find all of the lengths of these larger black outside lines. So I'm going to start in this corner. I've got a 60-degree angle, 90-degree angle, so that means this is a 30, 60, 90 triangle. This ends up being the radical 3 side. This is the 1 side, and this is the 2 side. So I'm going to go through and I'm going to figure out what those sides are, and I'm going to go and label my drawing. Now, obviously, I don't want you labeling in the book, so I advocate that you sketch out this on your homework so you can actually just write on your sketch in the book, or in the homework. All right, so let's solve for this side here. We'll call this an x, and we'll call this y. So I've got x over 1 is equal to 1.5 over radical 3. Now, I've done most of these calculations already, so I can go ahead and tell you what those values will be. In this case, I'll solve 1.5 divided by radical 3 will be, of course, not this, 0.86, 6 or 0.87. So we'll call this 0.87. All right, I want to solve for y. So y over 2 is equal to 1.5 over radical 3. And solve for that. So multiplying, I get 1.74. Okay, again, I want to go in and actually write in what I have here. So this is 1.74, and in this case, this is 0.87. This triangle is congruent to this one. I know that because of hypotenuse leg. I have a right angle. I have these are the same, and then of course the shared side is the same. So this is 1.74, and this is also 0.87. Moving on, I want to solve for this side right here. Now, I'm going to solve for this side using the fact that this side is one of my pieces of my triangle. So I will mark that in. 0.87 times 0.87 is 1.74, as we saw before. And I'll solve for that piece, and that piece I will call z. I'll end up developing quite a few variables here. I know that relative to the 55, this is my adjacent side, and this is my hypotenuse. So I can say that the cosine of 55 is equal to 1.74 over z. Solving, I know that my variable's in the denominator, so z will end up being 3.02. Okay, write that in here. Now, unfortunately, I don't have the ability to to move straight to another side. I don't have the ability to move straight to this side or this side or this side. I need this mesial side, and this is a very normal technique where we solve for something that's between two triangles so that I can get another side. I'm going to call this side W. It's not a very nice looking W there. That's better. So I can say that the sine of 55, of course that's opposite over hypotenuse, is equal to W over 3.02. And when I do that, I see that W is equal to 2.47. Now, if you're working along with your calculator on this and you're not rounding to 3 decimal places as opposed to 2, you might see a slight variation in these. This is just based on the rounding that I've chosen. A lot of times we can use our calculator to move one step to the next, and we'll see a slight variation in our values. As long as they're close, though, we're pretty good. So I've got 2.47. All right, now I'm going to use this value to solve for this, and we'll call that value, run out of the variables at the end, so we will call this u. Relative to the 55, this is the opposite side. That's the hypotenuse. So I can say that the sine of 55 is equal to, excuse me, u over 2.47. And in that case, u is equal to 2.03. Now, this problem, by design, has a bunch of congruent triangles. If we look, this triangle is congruent to this triangle via angle side. Excuse me, that's not correct. Hypotenuse leg. I've got 90 degrees here. I've got the hypotenuses are congruent, and of course that shared side. So the fact that this angle, or excuse me, this side up here is 2.03, that also ends up meaning that this is 2.03, and this is 2.03 as well. So the only thing that I'm left with, of course, is this piece right here, and we'll call this side V. Now, I know this is 55 degrees, because those triangles are congruent. And we said that this triangle is congruent to this triangle, so the 55 ends up being over here. Okay. And now I can solve for that, because I know that the tangent of 55 is equal to the opposite over the adjacent. 2.03 over V. And in this case, V ends up being 1.42. So I want to get the whole perimeter. That means I need to add all of this stuff up. So I've got 1.74. And I should tell you I'm going to start in this corner and work my way around. Plus 1.74 plus 2.03, and actually I have 3 of those, so I'll take that times 3, plus this piece, which I found to be 1.42, forgot to label that. 2.303, which I already talked about, and then this piece, which is 3.02. Adding all that stuff up, I get that the perimeter of this shape is 13.99 units. So, to recap, what I end up seeing is I start in one corner, and I get one value, shares the side, so I can move to the next. I can use the shared side to get to the next. Shared side to get to the next. I look for congruence in my work. I work my way around.